Hello friends, our today's aim is to have a brief review on JVM architecture. JVM architecture primarily consists of three main components, that is the class loader, memory area and execution engine. First, the class loader. It consists of three main phases, that is loading, linking and initialization. In loading, the .class file or the bytecode is allocated to the memory. Second, linking. It consists of three phases, that is verify, prepare and resolve. Once the .class file or the bytecode is loaded to the memory, verification occurs so as to ensure it meets the required set of standards. Then it is processed further. Second, prepare. Memory is allocated to the static variables and default value is assigned. Third, resolve. Symbolic references are converted to the actual references in this phase. Initialization. In initialization, the static variables are assigned their actual value. Second, that is the memory area. The memory area are broadly classified into two types, that is the stack area and the heap area. Method calls are implemented using stack area. Once a method is called, a stack frame is created in the stack area and then the arguments pass the local variables and the value to be returned by the method called all are stored in this stack frame. The heap area. The objects which are created are stored in the heap area. The third main component is the JVM execution engine. This is the part where the bytecode is converted into the machine. The four main parts of the execution engine are interpreter, just-in-time compiler, garbage collector and JNI, that is the Java native interface. First, interpreter. The interpreter is the one which reads the whole program and executes it line by line. The problem with the interpreter is that when a method is called multiple times, it interprets the bytecode again and again. Second, just-in-time compiler. It overcomes the issues or the problems which arise by the interpreter. When a method is called multiple times, the bytecode is converted to the native code and this native code will be used again when the method is called. This saves time. The just-in-time compiler has four main components to achieve these functions. First, the intermediate code generator. It generates the intermediate code. Second, code optimizer. It optimizes the code. Third, target code generator. In the target code generator, the native code is converted to the machine code. And fourth, the profiler. This is responsible for identifying the hotspots or the methods which are called multiple times in the program. Java garbage collector. Garbage collector is responsible for destroying and collecting the objects which are no longer used in the program. And last, the Java native interface. It is responsible for communicating with the class libraries and making it available for the JVM execution engine. So this sums up the JVM architecture in brief. Thank you.